Hi, good afternoon, everybody. My name is Silvia Martini, and I am a PhD student at the University of Bologna, where I also work as a neonatologist. Thank you for having given me the opportunity to present these preliminary data, which are part of my PhD project. So, we know that cardiorespiratory events are defined as intermittent episodes of transient hypoxemia associated or not with bradycardias. They are very frequent in very preterm infants because of their cardiorespiratory and hemodynamical instability. And we also know that they may possibly result in transient brain hypoxia and hypoperfusion. Moreover, if they tend to persist over the first months of life, they may also be associated with such unfavorable outcomes as neurodevelopmental impairment or higher rates of retinopathy of prematurity. The bunch of literature which is currently available on cardiorespiratory events, however, is mainly based on infants aged few weeks to few months, whereas data obtained during the transitional period, which is defined as the first 72 hours of life and is characterized by a significant hemodynamic instability, are almost lacking. Moreover, to the best of my knowledge, cardiovascular changes in response to these events have not been investigated yet. Therefore, we aim to assess the impact of different types of cardiorespiratory events on cardiovascular parameters, which were evaluated continuously and non-invasively in very preterm infants during the first 72 hours of life. To do so, we enrolled infants below 32 weeks of gestation or with a birth weight below 1.5 kilos. Those enrolled infants underwent an non-invasive continuous trend monitoring of cardiovascular and vital parameters during the first 72 hours of life. For the sake of data homogeneity, we decided to rule out mechanically ventilated babies, so all the babies enrolled were non-invasively ventilated. Cardiovascular parameters were evaluated by means of electrical cardiometry, a device that is based on the measurement of transthoracic bioimpedance, and the parameters that we looked at in the context of this study were, of course, the heart rate, also the stroke volume, cardiac output, cardiac contractility, and systemic vascular resistance. We associated the data obtained by the pulse oximeter, in particular the heart rate again, and the peripheral oxygen saturation in order to detect cardiorespiratory events. The data collected with these two devices were then recorded using the ECM Plus software. This is an analytical tool that allows simultaneous and synchronized data recording for multiple parameters obtained with different devices. Moreover, it also allows an integrated analysis of these multiple parameters. This software has been developed by the Brain Physics Laboratory of the Cambridge University, with which my PhD is in collaboration. From the ECM Plus traces, we then identified the following cardiorespiratory events, of which here I've provided the definition. Isolated desaturations, isolated bradycardias, and if the two events occurred within a 60-second time window, we define them as combined desaturations plus bradycardia. The ECM Plus traces were then visually inspected in order to rule out any possible artifact, and then we also tracked down onto a spreadsheet the following data. Baseline values, which were defined as the last stable values before the event onset, nadir values, which were those for each parameter concomitant to lowest SpO2 or to lowest heart rate, and finally we calculated the percentage changes between the baseline and the nadir values for each parameter, and we use these percentage deltas for the statistical analysis. The preliminary data I'm going to show are based on a population of 22 infants with a mean gestational age of 30 weeks and a mean birth weight of around 1.2 kilos. From this pool of infants, we screened 839 episodes, and after ruling out those who lasted less than 10 seconds, those with evidence of a partial signal dropout, and those episodes which were likely to be artifactual, for example, if we observed a heart rate discrepancy greater than 20% between the values obtained using the pulse oximeter and using the electrical cardiometry, we ended up including 767 episodes in the statistical analysis. Of these, isolated desaturations were the majority, accounting for around 60%, where isolated bradycardias were the least common events, around 50.8%. Whereas the saturation plus bradycardias represented 24.6% of the whole pool. Moving on to the percentage changes of each cardiovascular parameter, let's start from the heart rate. Of course, as it's accordingly to the definition of bradycardia, we observed a decrease in the heart rate during the saturation plus bradycardia or isolated bradycardia compared to isolated desaturation. But what about stroke volume? Looking at the stroke volume, we saw that the bradycardic episodes, either alone or associated with desaturations, when compared to isolated desaturations, were associated with a significant increase in the stroke volume. When it comes to the cardiac output, however, we can say that the impact, the effect of the heart rate drop in the determination of the cardiac output was predominant over the increase in the stroke volume, as we observed a significant decrease of the cardiac output in association with bradycardias, either alone or associated with desaturations when we compared these values with those of isolated desaturations. Moving on to the heart contractility, we evaluated the index of cardiac contractility, which is measured from the electrical cardiometry. And we saw that even though slight, there was a significant decrease in the heart contractility when the bradycardic episodes were associated to desaturation compared to bradycardias or desaturations alone. Eventually, as for systemic vascular resistances, we saw that this parameter was significantly increased in concomitance to bradycardias plus desaturation or isolated bradycardias compared to isolated desaturations alone. So what can we say from this preliminary data? As one would expect, I think it is actually expected, isolated desaturations had the lowest impact on the cardiovascular parameters, whereas desaturations plus bradycardias were associated with a significant drop in cardiac output, heart contractility, and systemic vascular resistances. We may hypothesize that the combination of hypoxia and the heart drop that occurs during desaturations plus bradycardias may play a role in the observed decrease of heart contractility, and in turn, the decreased heart contractility, the decreased cardiac output, and the increased systemic vascular resistances that we noticed during desaturations plus bradycardias may be associated with transient impairment in brain hemodynamics, and to this regard, we also had data from NIRS from the same pool of infants, and which had been discussed as a poster this morning. They showed actually a significant impairment of brain hemodynamics in association with desaturation plus bradycardia. As for the study limitations, of course, these are just preliminary results and so are based on a relatively small sample pool. And I'm sorry to say that we don't have available simultaneous respiratory plethysmographic data, which would have helped in order to discriminate whether the cardiorespiratory events we observed were related to apneic episodes or no. As for future goals, in addition to the further enlargement of the sample size as the recruitment is still ongoing, we are planning to include this data into a multivariate analysis in order to evaluate whether different neonatal characteristics, for example, gestational age or the ductal status or the ventilatory status, for example, may influence the observed cardiovascular response to cardiorespiratory events. Last but not least, I would just like to thank my Italian team for the work done so far, the Brain Physics Laboratory for their precious collaboration, and Professor Topunostin, who's my co-supervisor, for all the support.